Hello, welcome back to HAG'S Lab. If you have watched any of my previous videos, like the video running in the background here, you have probably seen my C64 emulator before. I thought it might be interesting to make a video where we take a closer look at it. We can look at the current features, the missing features, the bugs, and maybe even improve the emulator by fixing a bug or implementing a new feature in a later episode. So let me know in the comments if this is a series that sounds exciting to you. Before we continue, I thought we would talk a bit about the history of the project. I always thought that writing an emulator would be very interesting and challenging. There are obviously better and full-feature emulators out there, and the only reason for me to write my own is purely educational. So 3 years ago, that's what I did. Well, that's why I started anyway, and it's been an ongoing project ever since. As you can see, the project is open source on my GitHub page, and the plan is to implement even more systems in the future. That's why the project is called retrocomputing. Let's take a quick look at the repository on GitHub here. As you can see, all the code is obviously available. I have a README that describes a little bit about the project. And as I said, I plan to make more, maybe even more CPUs, but at least more systems based on the 6502 CPU later. So I've divided the README into the microprocessors and the computer systems. So for now I only have the 6502 microprocessor and the Commodore 64 system. And we can see a preview of the C64 emulator. This is running my C64 matrix program, which I have another video on, if you want to watch that. But let's just click into the Commodore 64 emulator subdirectory here. In addition to the GitHub page here, I have a GitHub page which is a little bit more readable. So let's just continue looking here. Let's go to Commodore 64 emulator. So if we scroll down, we can have a look at some old screenshots of the emulator to see how it evolved. So this is basically the first time I had output, like video output from my emulator. This is not a real video output. This is just me using a font to print out the screen buffer to a Windows form here. So as you can see, it works fine at this point. I also have a rudimentary keyboard input here, so I can actually write and run basic programs. But I don't even think I have, like timers, or you can see I have no blinking cursor. None of that is implemented there. But when I got this up and running, I was very excited, to say the least. And then I just have some random screenshots. This is definitely using the character ROM. But I think at this point I probably don't output the video like the VIC II does. I just use the character ROM to get the bitmap font and just print that on the form on the Windows window. But at this point I actually have background and foreground colors, it seems like. Here you can see that I'm actually doing some more things to the UI. I've added a toolbar at the top. Just some simple stuff: restart, CRT filter, which is just a bad CRT filter. It's just basically lines that is drawn on top of everything else. But I don't know, it's fun. I can copy the screen. I can open and save PRG files, I guess. I'm not quite sure how these characters are generated here. That might just be during a restart, but yeah, they do actually look really beautiful. Here we have some more GUI updates. I have added some icons that I've made myself. It's still the same items as earlier, I guess, just with icons. And here I'm running a keyboard test program to test my keyboard matrix implementation. It was actually pretty fun to implement that. That might be something we should take a closer look at some point. And here we can see the UI is evolving a little bit. I've added more items to the toolbar, and I also added a couple of status bars. So I have one for the VIC II and one for the CPU. Okay, so that's about it. Let's actually open the emulator and have a closer look at it. Okay, let's get started. Let's open the emulator and have a look. So the first thing I want to show off here is the color palette on the C64 is kind of stupid. I don't know why they have blue on blue. But what I do whenever I whenever I make a video and I use the emulator or an actual C64, what I do is always change the text color to white to make everything easier to see. And sometimes that's easy to forget. So what I did is that I added a feature here that's called white text color patch. And if we enable that and we restart the system, I'm sure you can guess what happens. We get the white text from boot, which is nice. So that directly on the fly patches the kernel ROM image to change the default text color to white. And I think that is a very nice feature to have, especially for me when I use this emulator doing the educational programming videos or whatever. So if you turn that off again, it just goes back to normal. But let's keep that enabled. Very nice. Since we were already looking at this colors menu, one of the latest features I added was the ability to import VIC palette files. So I have imported some palettes here now. We can also open the palette folder. So we can see that I have some JSON files for the palettes, and that is not the same as VIC. So when you import a VIC color palette, it changes the format to a JSON file. Yeah, we don't have to look at that right now, but as you can see, these are all the palettes available, and those are the same palettes that shows up in this menu. So if I change the palette, it changes the colors. Simple as that. So before we continue, let's just have a quick overview of the UI. The colors item here that's recently added, and I added this menu bar because this regular toolbar was getting a bit crowded, and I definitely have more stuff that needs to be added. And it's also nice to be able to add stuff to the menu without making the icons every time. And we have some functions there that are nice to be able to access quickly. And then we obviously have the screen output, and at the bottom we have two status bars. And this is showing data from the CPU and the VIC II. It can be handy to have it there, but it's mostly for debugging the emulator, to be honest. But the CPU shows the speed, number of cycles, instructions, and illegal instructions. The VIC II shows the current FPS, the VIC II cycles, the current raster line we're on, and the position within the line. We can also see the current video output mode. It's obviously just standard character mode for basic. And there's also a bit to turn the screen on and off in the VIC. In one of the VIC registers, so that's kind of handy to see, because sometimes when you think something is not working, and then the thing is that the screen is actually off because the program is doing something. The system right now is running as a PAL system, so the clock speed is supposed to be 0.9852 megahertz, but we can see that we're running lower than that, and that is because I've been trying to fix this, but the resolution for the timers that I can use in Windows using the .NET SDK, stuff like that, I cannot get it to accurately hit the correct frequency, which is annoying. So it runs at 92.27% at the moment. It's very steady, it's just the wrong speed, and I wish I really want to fix that, but I've spent so much time on it. It works, it's fine. So let's have a look at these quick features on the menu bar here, the toolbar. So first off, we have the power cycle of the system. Just completely, it's just like if you pull the plug on your Commodore 64 and put it back in. Next to it, we have the reset, which is more like if you have modded your C64 with a reset button or using one of those cartridges with a reset button. Let me just put something on the screen. So when you press reset, it just soft resets the system. And the pause icon just pauses the emulation, so it just stops the CPU basically, while the CPU and the... Well, actually doesn't stop the VIC, I think. At least it's still counting cycles. So I guess I could have done that, but I do not. Next up, we have load and save program. So if I do, let's do 10 print testing save program. 20 go to 10. That is working. So if I save that, and I've already saved a hello program, but let's just do testing.prg. Oh, don't need to add that. Testing, and we power cycle. The program is obviously gone. And then we can load, and we'll choose testing, and there we go. And also it loads the PRG, and it also auto runs, and I think that should be a feature that we add, so we can disable the auto running of the program if we want to do that. But if I stop and I do list, there's our program. We can also try to load hello. That's just a hello world program. I have not implemented any disk drive routines or anything like that. This is purely loading and saving basic programs. Well, it doesn't have to be basic. Well, PRG files in and out of memory. Next up, we have the beautiful cartridge icon here, which I'm actually pretty happy with. So yeah, you better be as well. That obviously loads cartridge images. I don't have support for any of the fancy cartridges like the freezer cartridges and stuff like that, but basic cartridges, no pun intended, should work fine. So let's just try Simon's Basic here. So as you can see, the title of the cartridge is shown here up on the button now, and that shows as long as the title is part of the CRT header. So we can see that loaded fine. And if we click that once more, it just removes the cartridge from the system. We can also try the Diagnostics cartridge. And we can see that starts running the Diagnostics as intended. And you can actually see some bugs here. We have, oh, that's part of the test. Let me just wait for the for the test to continue. Yeah, so you can see that I have some issues with the clock down here, so that's part of the CIA, and that is a bug that we need to fix at some point. I'm gonna pause now, because we can see that we have some bad stuff going on here. So first off, the kernel ROM, that shows up as bad because the checksum doesn't match the actual ROM, and that is because of the white text color patch that we have enabled. So if we were to disable the patch, it would show up as okay. But since the kernel ROM has been modified, it shows up as bad. Cassette, keyboard, control port, serial port, user port, all of that needs a test harness on a real 64 to show up as okay as well. So that's basically not tested correctly, but I don't have any cassette stuff implemented. I obviously have keyboard. Controller ports, I have not implemented emulation of the controller ports yet. That is something I want to do. The serial port, I have nothing doing that. I kind of want to do that as well, to be able to emulate a serial port. And user port, we could emulate some hardware that uses the user port, but I have nothing implemented so far. And you can see timer 1 and timer 2. This is a bit interesting because timer 1A is okay, B is bad, and timer 2 AB is also bad. And I know I have some issues with the CIA implementation, which is the CIA chips in the C64, which handles timers and some other stuff, but the timer implementation is definitely bad, except for timer 1A. And timer 2 should be the same because it's the same chip. There's 2 CIA chips, but I actually have 2 different implementations in my emulator, even though they should function the same. So not sure completely why that happened. I think I just started making another CIA implementation and I just switched one of them inside the emulator. But that's definitely something we need to have a look at some point. The interrupt test, I'm not sure what that does and why it shows up as bad. I definitely do handle interrupts in my emulator, but must be something. And we have some chips that are better. I think one of those are probably the kernel ROM and SID, I guess. And yeah, CIA. Must be. So let's unpause. I guess I could turn off the color patch so we can actually see that the kernel ROM shows up as okay. Let's just wait for it to get to that point. There we go. So you can see kernel ROM, okay. So that's definitely just calculating some checksum of the ROM, and if it doesn't match what it's expecting, it's gonna show up as bad. But that's basically it for the cartridge functionality. We can just we can unpause and remove the cartridge again. And let's also activate the white patch. There we go. This next section is just a few features that changes the video output, like the actual screen that we see here. So the first one is a rudimentary CRT filter kind of thing. It's actually just a static PNG that is drawn on top of everything else. and that is just to save on FPS, what should I call it, drawing resources. I have no GPU acceleration in this. It's all just GDI based, which is a 2D drawing framework in Windows, and it's not very good. So at some point I would like to swap this out with some, I don't know, SDL or something similar, but for now it's okay. But you can see if I disable this filter, I actually gain like 13 FPS, which is kind of stupid. But anyway, the next one is OSD, on-screen display, and you can see that the messages just stack on top of each other. I added this because I wanted some feedback on the screen, because I made a feature that if you load a PRG file and that PRG file changes, the emulator automatically reloads it, and that is very useful when I do debug sessions. When I make programs and I recompile the program, the emulator automatically reloads the program. So what happens then is that a message is written on the OSD to say that something.prg reloaded. You can see that the FPS with this enabled is also very low. It's over 20 FPS. And I think that's because I really wanted this to look like one of those old VCRs, like the OSD on some of this old equipment. And I think I did that okay, but the way I do it is that I print this text and the shadow on a small frame buffer, and then I scale that up and print it above everything else to make it have that grainy bad look. And I love the look, but it ruins the FPS, so that needs optimizations for sure. Still cool though, I think. It really gives me the VCR vibe. This icon is a full screen mode. I'll click on it, but it's gonna ruin the capture, but let's give it a go. There we go. It just stretches the video output over the whole screen, so not very useful. And also the FPS is horrible on this as well. I'll show you with a program here. It's very choppy. And if you drag the mouse to the top, it shows you the toolbar. And if you click it again, it goes back to normal. At least sometimes. I know I have a bug there, so sometimes when I go back to Windows, it actually screws up the aspect ratio and everything. Not quite sure what causes that. I think it's something. What is it? If I activate this and then do full screen. Oh yeah, there we go. I also have, like, if I double click on the window, it just fixes the aspect ratio. But I have a bug there as well, so it just keeps growing when this bug happens, which is kind of strange. Oh, yeah, so I have a lot of bugs. There's a lot of things to fix. Let me know if you want to watch it. Anyway, let's try and get back to, let's close that. Let's restart. There we are, back to normal. This beautiful camera icon is a screenshot feature, and you can see I have a drop down here because I have two different modes. If I just click this button, it's gonna take a screenshot of whatever you see on screen here. So if I add the CRT filter and I do this, and then I'll open MS Paint and I'll paste, you can see that we see the whole video output here, including the CRT filter. And I think also if I add, let's see if I add that, and also OSD, see if all this, yeah. So that just gives you the whole thing. And if I do copy raw, see what we get. Yeah, okay. So we still get the VIC II things, like this border around the frame and main area extents. We also get the parts of the image that isn't normally shown. So the blanking areas. But we also get a unscaled, crisp pixel for pixel representation of the output, video output from the VIC. So that's why that looks crisper. But yeah, so that just gives us the crisp raw screenshot. Okay, let's continue down the toolbar here. The next feature is this nice bug that I've made here, bug icon, and that is a debugger. And I'm gonna save that for some later time because I think that's something we need to definitely improve. It's not working as it should anymore because I've abandoned it for now, which is stupid because I could really use it sometimes. So I really want to do some work on that. I've also looked into actually adding support for external debuggers like GDB. So let me know if that's something you would want to see in the future. Next 5 buttons are for controlling the CPU frequency, basically the crystal in the C64, and it annoys me with this frequency calculation, and the stuff doesn't work like properly. What do I have here? So the double minus brings it down 10%, and the single minus is 1%. But it is kind of useful for debugging stuff, and I'll show this off when we get to these next some of these next features. So these last 4 buttons, those are debugging tools for the VIC II. First one is for showing the extents of the different parts of the screen. So we can see that we have outlines on the main screen area and the border area. And if I were to click on this icon, it's going to show the whole part of the screen, because if you know how these old video signals work, you actually have parts that are not shown on a CRT screen, but it's still part of the signal, and it needs to be emulated to do proper screen emulation. So when I enable this, it's going to screw up the capture a little bit, but let's just try. Yeah, we overflow a bit, but let's just squeeze it. So now you can see that we show the extra areas to the left and right and top and bottom of the screen, and this is the the horizontal blank and the vertical blank. And if I were to activate this feature, we get this white flying dot. I don't know how that shows up on YouTube after encoding and stuff, but that is the current position of the beam, of the raster beam. So that's how the image is drawn basically. And now we can try and turn down the frequency here so we can see this better. Yeah, so you can see that it draws the image 8 pixels at a time, because that's how the VIC does it. When the VIC II is building the image, while outputting the image, it clocks 8 pixels at a time. We can see that I just drew the cursor here. There we go. And if we have a look here, we can see that the current position is now outside the actual image on line 305. And we can see the position as well. Okay, so I restarted the emulator and I'm gonna open a program here. Let's do HAG'S lab. That's just an animation I made. It's actually an Easter egg in the Retro Hour episode guide. I'll link the video if you want to watch that. But so this demo, or whatever you want to call it, is constantly changing the border color. So if I were to decrease the frequency here, we'll see that this happens less frequently, and that in turn make every raster line here a bit taller. And if I were to there we go. So if I activate this feature now that shows the position, we can see that follows the drawing here. So we should be able to see, yeah, so the line changes color from red to gray. And that's important if you want to have an accurate emulation of the video output, because if you just do this on a frame by frame basis, it's not going to look like the real thing, and it's definitely not going to give a good representation of demos and effects in games unless you do this. So let's see if this changes color soon. So that's that. There's one more VIC II debug feature, and that is this button right here. And that's going to show whenever there's a raster interrupt enabled in the VIC II register, it's going to draw a line on the image here wherever that interrupt is supposed to happen. So if a program sets up a raster interrupt on line 112, it's going to show the line here at line 112. So that's just for debug purposes. So let me open, I'm going to open Donkey Kong, which definitely sets up some raster interrupts, and let's have a look. There we go. So that's the red line there. Whenever the VIC II gets to this line, it triggers an interrupt on the CPU that lets you do stuff. And a lot of demos use that for changing the video mode mid-frame. So that would mean that you could do a standard character mode for one part of the screen, and then when you get the interrupt you can change the mode to do bitmap mode, and then you can output a bitmap for part of the frame, and then you could, if you then also just change the raster interrupt, you can change it back to standard character mode at the correct time. I don't know if that made sense, but I think I have. Not sure what this is, but I know that it has some, yeah. So you can see that the raster interrupt changes here. And unfortunately I don't have bitmap mode implemented, but this program is definitely using the raster interrupts to change the video mode on the VIC. And one more thing, these yellow rectangles, that's actually me currently trying to implement sprite support. So all of these yellow rectangles are supposed to be sprites. And maybe that's something we can look into at some point. You can see that these raster lines actually do line up with the sprites here, so I guess this is used for some kind of animation. So as you can see, this I've done a lot of work on this emulator, but it's missing a lot of features. Let's turn it off, let's restart. So that's it for this video. We didn't do any deep dives into too much technical stuff, but definitely let me know if you do want to see that, and what do you want to see? Do you want to see more of the code? Well, we haven't seen any of the code. Do you want to see the code? Do you want to see me adding features, fixing bugs? Do you want to see something completely else? If this series is not interesting, let me know. If it is interesting, let me know. I'll see you next time.